How to get better results from your LLMs whenever you're using LLMs. This is actually a fascinating research paper that I stumbled upon. It was published by the Microsoft research team and the Salesforce research team. I read it this morning, and I actually changed, based on the research, I changed the way I'm using Windsurf and the way I'm interacting with LLMs in general. I don't have conclusions yet, but this research paper is very interesting and kind of shifting the way that I'm going to interact with the LLMs. And this is why I wanted to record this very short video and go over it with you guys. I will try to keep this brief. If you're interested in diving into the nitty-gritty, please just make sure to check out the link which I'll drop in the video description. It will have the link to this research paper. Now, the main idea is the fact that when LLMs are measured, they usually are measured in a single turn. So when you provide a prompt, and then based on the output that you're getting, this is how the quality of the output that you're getting, this is how many benchmarks are determined. Now, in this research paper, they wanted to check how does doing a multi-turn conversation with the LLM, how does it impact the quality of the output? So let's say if you send one prompt, very detailed prompt, this could be one thing. But if you're starting to go back and forth with the LLM, trying to architect your workflow or the web apps that you're trying to build, what are the implications of just generating a larger context window and actually going back and forth? So this was a very thorough and detailed research that they did. Let's just start reading through, and I will skip all the stuff that is irrelevant or that is not so crucial. So, as I say, even though a growing body of work proposes to evaluate LLMs in a multi-turn fashion, we identify in our review that most prior work treats the conversation as episodic. Conversation turns might relate to each other, but the conversation can effectively be decomposed as an array of subtasks that can be evaluated in isolation. We argue that episodic tasks move away from what is prevalent in human conversation under specification. In this work, we close this gap by creating a simulation environment for multi-turn under specified conversations, sharded simulation, that leverages existing instructions from high-quality single-turn benchmark. At a high level, the sharding process, we will cover this in a moment, we propose transform existing single-turn instructions into sharded instructions, a set of smaller instructions that jointly deliver the same information as the original instruction. So, for example, let's say that I want to build a to-do list web app. On one hand, I can perhaps build like the full PRD in Claude or ChatGPT, and then just pour it into Windsurf with all the details, checklist for the progress, the exact steps that for the roadmap, the tech stack, etc. Alternatively, I can provide all of these details, but just in multi-turns while having a conversation with the LLM via Windsurf or Cursor or whatever coding assistant that you're using. Now, they want to investigate what is the performance, what is the difference in performance if you're using one shot, like providing everything up front, versus providing all the details, dripping all the details during the conversation. Now, let's move forward. Okay, so basically what they did, we have the fully specified instructions, the original. So for example, Jay is making snowballs to prepare for a snowball fight with his sister. He can build 20 snowballs in an hour, but to melt every 15 minutes. How long will it take before he has 60 snowballs? So this is like the full instructions, the full riddle in this case. On the other hand, we have the sharded instructions, which are basically similar in content to what we have here, but they are broken down. So how long before Jay is ready for the snowball fight? He's preparing for a snowball fight with his sister. He can make 20 snowballs per hour. He's trying to get to 60 at total. The problem is that 2 melt every 15 minutes. So basically, as you can see, it's the same context, but we want to see how this impacts the performance. So what they did, they have different types of simulation. So the first is like the control. We have the fully specified instructions. It simulates a single turn, fully specified conversation in which the original instruction is provided to the LLM in the first turn. This simulation type evaluates baseline model performance on task. Next, we have the Sharded. Simulates multi-turn, under-specified conversations as outlined above. Sharded simulations are primary tool to evaluate model performance in under-specified multi-turn conversation. This is a graphical representation of what is the Sharded. So it's the full context, but broken down into turns. So one piece of info here, another piece of info here, another piece of info here, etc. Next, they have a different simulation, which is called concat, which basically simulates single turn, fully specified conversation based on the sharded instructions. The shards are concatenated into a single instructions in bullet points form. So it's similar to this, but this time it is provided as bullet points with all the context in one turn. Then we have the recap simulation, which simulates a sharded conversation and adds a final recap turn, which restates all the shards of the instruction in a single turn, giving the LLM one final attempt at responding. So basically, recap is a combination of the sharded simulation followed by a concat turn. So as you can see, the recap, we give one shard, second shard, third shard over here, and then a recap. Then, last but not least, we have the snowball, which basically takes the recap simulation a step further, implementing a turn level recap. At each turn, let me close this. At each turn, the user simulator introduces a new shard, but also restates all the shards that have been revealed so far in the conversation, producing a snowball effect as each turn reveals all the information from the previous turn, plus one additional shard. So it looks like this. So first we have the first shard, then we have the second shard plus the recap, then we have the third shard plus the recap, etc., etc. So basically, it's as if you have, let's say you want to build a web app for the to-do list. So over here you share all the specifications in one turn. Over here, you share one specification. So I want to use Next.js. Then I want to use MongoDB. Then it must be mobile friendly, etc. Over here, you have all the context from here, but broken down in bullet points. So I want Next.js, I want MongoDB, I want mobile responsiveness, etc. We have the recap. So basically, we're saying I want it in Next.js, I want it in Next.js and MongoDB. Just as a reminder, so far we discussed we want Next.js and MongoDB, etc. And over here we have again adding a piece of a shard and also the example, like the recap. Now they selected 5 different tasks. I think it was 6. Sorry. So one is generating code. Another one is generating a schema. Let me just read it because it'll be easier. The assistant is provided with a schema of an SQL database and a user query in natural language and must produce an SQL query that retrieves the requested information from the database. Then it has a API-related task. Then it has a math-related task, data to text-related task, and a summarization task. For each task, they use different benchmarks, and then they are saying basically that they chose 15 different LLMs. I just want to move forward for the bottom line, So they chose 15 different LLMs, as you can see here: Llama, Anthropic, Free Haiku, 4o Mini, 5.4, etc. Over here, you have a breakdown of the performance in each task when the task was the prompt was full. Then we have when the prompt used the concatenated sharding, yes. And then we have the results when sharding, and then the overall results per model. Now, for each task they are saying, and this is what is showing in the table above, conversation are simulated in three settings: full, concat, and sharded. Models are sorted in ascending order of full average scores across tasks. Now let's move forward to the results. So table 1 summarizes results from the simulation. At a high level, and this is the most important thing, and this is what I believe we should take away. At a high level, every model sees its performance degrade on every task when comparing full and sharded performance with an average degradation of minus 39%. We name this phenomenon lost in conversation. Models that achieve stellar performance in the lab-like settings of fully specified single-turn conversation struggle on the exact same task in a more realistic setting when the conversation is under-specified and multi-turn. In comparison, models perform roughly equivalent in concat settings, with concat performance averaging 95.1% of the full counterpart, which is very interesting. This implies that the loss in performance for sharded is not explained by potential loss of information in sharded instructions, as such loss would be reflected in lower concat performance as well. So they also observe that smaller models have more pronounced concat degradations, and they interpret this as indicating that smaller models struggle to generalize as well as larger models. Benign rephrasing affects performance more than for larger, more robust models. This is interesting. Moving forward. Okay. So they say results presented in table 1 present average performance degradation. We now report on the aptitude and reliability analysis based on metrics A and U. So basically, aptitude is the best case performance. Reliability is the variance between the worst case and the best case. In summary, in single-turn settings, models with higher aptitude tend to be more reliable. This fact is known in the community, with arguments made that better models require less prompt engineering and they are more robust to minor variations in input and output. Moving forward. Then what they did, they wanted to isolate the problem, which was very interesting. So the multi-turn conversations simulated based on sharded conversation are not representative of under-specified conversations that users might have with LLMs in realistic settings. In particular, the fact that sharded instructions must be maximal and that the simulated user must reveal at most one shard of information per turn can seem unrealistic and adversarial. In fact, prior work, moving forward, let me see. Okay, let's go to the implications. So, building LLM-based applications typically involves complex processes, decomposition of problems, retrieval of information, use of tools, and calling of actions. Such processes are typically orchestrated by agentic frameworks, AG2, AutoGen, LangChain, etc. That allows system builders to compose workflows with LLM calls as individual blocks. As such, an argument could be made that multi-turn capabilities are not necessarily a feature of LLMs, as it can be offloaded to an agent framework. In other words, do we need native multi-turn support in LLMs when an agent framework can orchestrate interactions with users and leverage LLMs only as single-turn operators? To answer this question, we implemented two agent-style conversation simulations, Recap and Snowball. Both pre-process users' utterance before sending them to the LLM. In Recap, a conversation proceeds in the same way as Sharded, but a user turn is added at the end, which does a recap of all previous user turns. And Snowball is a more gradual recap. At each turn, the user simulator reveals a new shard and repeats all previously revealed shards at that point. Now, let's see over here. So they say, while Recap outperforms Snowball, we note that Recap is an unrealistic setting because the intervention is conducted on the last turn of the conversation, which is not known a priori when conversation unfolds with real user. Snowball gives a sense of realistic performance gains achievable through user turn repetition. It can mitigate the full to sharded performance the deterioration by 15 to 20%. In short, relying on agent-like framework to process information might be limiting, and we argue LLMs should natively support multi-turn interactions. Then they give a few more recommendations to NLP practitioners and implications for LLM builders, which I'm going to skip because we are not an LLM builder. Then they discuss implications for users of conversational systems. Okay, so this is interesting. Users of LLM-based products should be aware of the lack of reliability of LLMs, particularly when used in multi-turn settings, very often. Generally available generative AI technology is new, and prior work has identified the randomness in LLMs generated text as a point of confusion for users. We take two practical recommendations that can help users of LLM-based systems get the most out of their exchanges. First, if time allows, try again. If a conversation with an LLM did not lead to expected outcomes, starting a new conversation that repeats the same information might yield significantly better outcomes than continuing an ongoing conversation. And I'm sure this is something that you also felt in your own experience, but this kind of confirmed what I felt, and I'm just going to start over more often from now on. This is because current LLMs can get lost in conversation, and our experiments show that persisting in a conversation with the model is ineffective. In addition, since LLM generate text with randomness, a new conversation may lead to improved outcomes. Now, another alternative is consolidating before retrying. Since LLMs are ineffective at dealing with information disparate across multiple turns, consolidating information consolidating the requirements into a single instruction is an effective strategy to improve the model aptitude and reliability. When a user notices that a model is lost in conversation, they can ask the LLM, please consolidate everything I've told you so far, then bring the response to a new conversation, alleviating the need for manual consolidation. In practice, there is anecdotal evidence that early adopters of LLM-based applications are aware that the LLM get lost in conversation. For example, users of the Cursor LLM-based coding environments report that frequently creating new conversation whenever they can is recommended strategy to ensure high-quality responses, even though the tool allows to keep conversation going indefinitely. Now, there is the conclusion. Basically, the main point is LLM get lost in conversation, which materializes as a significant decrease in reliability as models struggles to maintain context across turns. Why is this? The assumption is because they make premature assumptions and they over-rely on their previous responses. So if they did like one incorrect turn or one incorrect assumption, they just keep on building on this incorrect foundation, and this is where shit hits the fan, and then it's a snowball or more like a shitstorm because things are going just to become worse and worse. So let me see. Yeah, I think I covered everything. I hope this was clear. I obviously urge you to read the whole research because it's very interesting. Also, the way that they conducted the research, the way that they isolated the variables in order to understand what is the issue, or better understand what is the issue. I think the main implication for me is doubling down on starting new conversations, even though the models are having bigger and bigger context window. Google has, I think, 1 million tokens or 2 million tokens already. It doesn't mean that they know how to handle these very large context windows effectively. So consolidating all the data and restarting a conversation is probably a very good practice. Obviously, many users of AI coding assistants, Klein, Rucode, perhaps Cursor and Windsurf, they have you should have this file that has the bottom line of the project with like a checklist of the progress. This is very valuable because this is like a kind of a rolling context which you can always refer to even if you start a new conversation. That should be like the summary of the goal of the project. So doubling down on this, doubling down on starting new conversation whenever you feel that things are getting out of hand. Yes, that's pretty much it. I hope you enjoyed this video. If you did, please like and subscribe. Obviously, leave your comment below with your feedback. And until next time, keep on automating.